Alrighty, good afternoon, everybody. Happy Tuesday. Unfortunately, this time my mistake. I recorded the entire online class. I didn't use Microsoft Teams like I said I would because of the problems it was causing, but I forgot to switch the view. So the camera was just on me the whole time and it never showed the code. I didn't realize that till after the fact, and so I'm re-recording this now for everybody. Okay, so let's take a look at, actually, let me just make sure, yeah, we're good, where we're going this week. So what I want to do is off our website, off our 30S page, this week here, during this week, is I want to go through completing the class's example. Last week, I had to shorten up the online class because of a school staff meeting going on online. And this week I want to complete the class's example and just get a start on one of the class's assessment problems. That then assessment problem will be continued and completed next week, along with starting the graphics example next week. Graphics is not one that I would have ever assessed you guys on. I wouldn't have had any assignments or tests on. It's usually an extras unit in the 30S course. It's exciting because making graphics and stuff, but it helps prepare for the final project type stuff. But this week is the completion of the classes unit. Okay, so as you can see here, there's lots of resources for this. The folder of everything, the videos, the presentation notes, the GitHub example that we started last week, the assessments document, or the alternative. So if you go to GitHub, you can right now download the entire example from last week, and probably by the time you're watching this video, you'll be able to download the entire example updated from this week as well, including all the comments. Or if you don't need to download the whole thing, you can certainly go inside and grab pieces of code from it. The presentation notes are important. Last week we talked about the basics of what a class versus an object is. We talked about the idea of properties and methods. We talked about the difference between a class and an object. Now we did that just briefly through the example I was coding in. To know this in more detail, you should definitely read through this or watch the more formal videos on classes where I go through this, where it was recorded live in class in more detail. So then classes and objects and properties and methods. We made a person class. We created that class. You learned how to do that. We wrote the methods, we wrote the properties, we looked at a special method called a constructor method. We created that. We talked about how you can overload the constructor method, make multiple versions of the same one. We talked about the special use of the keyword this that you can use when making constructor methods. We added a few more methods, and then we got started making something called a student class. But before we did that, we also looked at a neat concept called encapsulation, making things public or private and how that relates. So I try in the notes to put an analogy in place about that, what the difference is and how that relates to this neat concept of encapsulation. Okay, so we did that. We added the words public and private to our code, both in our properties and in our methods to do this. And then we got started with the student class. And the student class starts on the path of an important concept known as inheritance. All right, so that's kind of where we sort of left off. So here's our example. Okay. It all starts in main, as it always has, with some methods that I've commented out from our first unit, our methods unit, and our classes unit. And now we're going to learn about classes, so I'm going to jump to that method. Last week we created a person object and had them invoke or call the method talk within the class. We also talked about what a constructor method is, and then how you can create a second constructor or overload the constructor method. Okay? Then we made another person object called other. Constructed it, called upon talk, called upon methods like birthday, which is also an overloaded method. Same name method, different parameters. And even a die method was called. We then made a third person with a third constructor option that we created. Now we can assign them their name, their age, and their gender all at once. We can have them talk. We can change their gender and their name through the public properties that were available. So that's about where we left off, where if we ran that, you can see that our first person talks, our other person talked a few different times with different changes. We even had that person die and talk, and then our third person talked, right? Sorry, I guess this is our third person right here. So that's where we were. Where we then finished off last week was just starting the student class. A student is a person, which uses the power of something called inheritance, and the keyword extends here. So when a student extends a student is a person. It inherits or picks up all the properties and all the methods of the class it inherits from. So I don't need to recreate name and age. It inherited that. I don't need to recreate the birthday method. It inherited that and all the other methods. So what I did do to the student class was I added 3 new properties: a student number, a GPA, and a stress value for each student. I then also created a constructor for the student class, which takes the name, the age, the gender, and the student number, okay, assigns the name, the gender, the age through the birthday method, the student number through this student, whereas the other ones come from the super class, which is the one it inherits from, and then assigns the GPA and the stress values of 0. Then what we did, and unfortunately I did this live, but I'm just covering it now, we wrote a method called study, and the study method changes the GPA and changes the stress by raising both of them. It raises the GPA by a value of 1.1, and it raises the stress by a value of 10. GPA is a double, stress is an integer. So we just did that for fun. This one says GPA equals GPA plus, whereas this one uses a little shorthand, which means stress equals stress plus. We then made a method called cram, and cram is just studying 10 times. So we use a loop to continually keep studying and studying and studying, calling the method we did up here. Then we had a method called slack off. Slack off has the opposite effect. It reduces your stress by a certain number, but it also reduces your GPA by a certain number. That number comes from another method we're going to create called YouTube. YouTube will give you back a number that will reduce your GPA. It has a parameter, which is the amount of time you're on YouTube, and it returns a number to you. So this is, again, incorporating stuff from our methods unit. This method, YouTube, we made a private method. It doesn't need to be public. It is only called upon within the class. So it's what's called an encapsulated method or a helper method. The parameter time is used in the loop to keep looping that many times. Starts with an amount of 0, adds 2 to it each time through the loop, and then returns that amount to calculate how much your GPA will be lowered, what the amount it will be lowered by spending time on YouTube. And that was just for fun. Finally, the last method in the person class is a neat one called the talk method. And talk is what's called an override method. So that incorporates this little thing right here called an annotation. It's essentially like a comment in Java, and you don't really need to know about that, but that is often suggested with a light bulb to add that. So what the talk method does is it overrides the talk method from the person class. So I already had a talk method in the person class, and now I'm overriding it with this new method. I'm just going to take this method out for a second. I'm just going to remove it as if it didn't exist. And go back to our testing code. So here I'm going to make a student called student person, age 17, is a male, student number 100, have them talk, have them study, have them slack off, have them cram. I can call upon birthday because that's a method I inherited from the person class, and have them talk again. And if I run that, student person is created, as you can see here, okay, at 17, and then later talks at 18 because of the birthday. But that's calling upon the talk method of the person class. When I use a override method, and now it talks in its own way as a student, it now will override that other method and output these 3 lines of output. But I can also still call upon the other method, talk, from its parent class person by just saying super.talk. So one talk method can call the other talk method without a problem. Now when I run this code, we'll see a little more detail out there. So now our student person right here is 17 when they first talk, and now you see these other outputs happening because of the override method. Their student number, their GPA, their stress. But then you might remember I called upon studying and slacking off and things like that. So you can see now their GPA is changing, as is their stress level is changing. Plus, the birthday method has increased their age from 17 to 18. So all those things are happening now. And that neat method called the talk method is an override method. We saw this in the notes that the student class does this, and it has these methods. It overrides with this talk method. Okay? And that's how it works. Okay? And how that all relates to inheritance and stuff like that. Then what we did was we talked about, let's expand this diagram out to not only have a person and a student, but also have a teacher and eventually a husky. Okay? Starting with the teacher class, what we did was we made a class called teacher. So now our project over here has person, it has student, it has teacher. It's going to have a few more classes before we're all said and done. And a teacher is a person, so it extends person just like student did. So it inherits all the properties and methods. But also what's interesting about this class, teacher, it is a person, okay? But it also associates with the student class, but not through inheritance. It uses what's called the has-a relationship, okay? Which is an association with one class to the other, okay? Or just using the other class. So a teacher has a student. So that's what we had there. We had the teacher class, okay? Oops. Let's try that again. So here it is, an array of students, a whole array, a private string for which course they're taking, and a constant for the maximum number of students this teacher can have. We then made a teacher constructor, a constructor for the class, where I say, here's the name, here's the course, I pass the name along to the superclass, I assign the course, I don't worry about gender or age, and then I build up an array of the maximum number, or 100 students. We then wrote a method called teach. A teacher teaches. We loop through to the maximum number of students, and as long as it's not a null inside that array, I make that student call on their study method. So I force each student to study. And then I also did this with a talk method, where I loop through the students. This time, instead of looping to max, I use the array.length. In this case, the array is called students. Same thing. And again, I also use this if statement just to back up on that. The reason I check to make sure the spot's not a null is this is an array of student objects. It's not like an array of integers. So each spot in the array will be filled with a null value until you put a student in there. And so then I'd have each student talk each time through the array. When I talk, I output a little bit about myself. I say, well, I'm teaching this course, but then I go through and have every student talk as well. So then we created a teacher object. We said teacher equals new teacher, called teacher person. And the course they're teaching is just called learning. We then assigned spot 0 of the array to be our student object. Because we made the array public, we could pick up the student object and assign it into the array at spot 0. We then also picked up spot 1 and spot 3. Let's make that spot 2. Not that it really matters. And created what are called anonymous students to go into the array right there. So we just created the students right at that moment in time. Each have their own age, their own gender, and their own student number. Let's change the age of this one a little bit. Then I called on teach, and then I called on talk. And let's see how that ran. All right. So, our female teacher was originally 0, teaching learning. Okay. The age, as we said, didn't matter for a teacher, as the gender didn't matter for a teacher. So our name, teacher person, okay, is teaching the course called learning, and then each student goes and talks. So the first student talks, second student talks, and then we even had our third student talk, Peter Parker, okay? So that all worked out nicely. Then we also made a husky object. All right. The husky is a student. So it's using inheritance, but because a student is a person, we have a double inheritance happening now. We're inheriting from both the student class and the person class. So we inherit a lot of properties and a lot of methods. We made one property for the husky class, how much pride, and we just made that a Boolean. Either they have it or they don't. We made a constructor for the husky class, where we assign their name, their age, and their gender through the superclass, and we just assign them the student number 1. So that's called the super constructor, and we just assign them their pride to be true. We then made two methods. One for homework, where we call upon the cram method of the superclass, and we take away their pride when they're doing homework. And then a method called pep rally, where we call upon the slack off method of the superclass, and we turn their pride back on when they have a prep rally. Okay. Finally, we also overrode the talk method of the husky class, where we call upon the talk method of the student class and then just finally output whether or not they have pride. And if I run that, well, actually, let me show you first. We made a husky object. Husky, named Havoc, 18, is a male, had them talk, had them do homework, had them do a pep rally, had them do homework again, and then they had them talk again. And the output for that would be these two things here. So at first, here's our male Havoc, has no stress and no GPA, but then they have a GPA and they have stress, and their pride is either true or false because of the different methods we called and the way we kind of called them. Okay? So that would, again, be how we looked at these different ways class can associate with one another through is-a and has-a. And then we concluded the unit with this fancy concept of polymorphism. And polymorphism is a fancy word for multiple shapes. Okay? And it explains in the notes what it essentially means in computer science. And to do that, we then adjusted our example to have what's called a meeting class. And this has a relationship with the person class through an array, so very much like the teacher class did. So it has an array of members of type person. It has an index number and a maximum. The constructor for the meeting class constructs the array to that maximum and sets the index to 0. We then made a method to how to attend this meeting. and we made a parameter, the person who attends this meeting. That person is assigned to that index in the array. Then, if I call this method again, I can't assign it to the same spot. The index goes up by 1. So the next time this method called, it goes to the next index, and then the next index. However, a little error check, if that index exceeds the maximum number, then I just put the index back to spot 0. Finally, we made a method called hold, how to hold the meeting. So we start with an output saying the meeting begins with this many members, because index essentially counts them as well. We had a loop where we loop through up to that index and had every member in the array call their talk method, and then say the meeting was adjourned. So we concluded the example by creating a meeting object, and then attending will be this person, this person, this person, as well as all these objects. You might think, well, that's a student object, a teacher object, and a Husky object. That's true, but a student is a person. A teacher is a person, and a Husky is a student, and a student is a person. So through this fancy concept called polymorphism, the method accepts all of those as parameters because they're all of type person. And then I held the meeting. And when I ran that, all the code for the entire meeting, which started here with 6 members, the first person, the second person, the third person, okay, the student person, the teacher, which means that all their students will output as well, and finally our Husky person, were all outputted one by one as the student, as the meeting went on. And that was our class. Okay, I apologize again that the recording didn't go as I anticipated it, but that should cover it. And I will put all that code up on GitHub. And please email me if you have any questions. I will see you guys next week for our next online class.